Welcome back to the channel. Today's video isn't about hype, price charts, or short-term market noise. It's about something much bigger that's quietly happening behind the scenes in both blockchain and artificial intelligence. While most people are focused on trends, tokens, and speculation, a much deeper shift is taking place. A race to build real decentralized infrastructure for compute, data, and AI that doesn't rely on centralized companies like Amazon, Google, or Microsoft. This video breaks down the real numbers, the real architecture, and the bigger picture of why one blockchain, the Internet Computer Protocol, is starting to separate itself from the rest. This video is for informational and educational purposes only. It is not financial advice. Always do your own research and consult a professional before making any investment decisions. Over the past month, developer activity across crypto has shifted heavily toward artificial intelligence, big data, and decentralized compute. Instead of focusing only on price-driven narratives, builders are starting to prioritize real infrastructure. Major ecosystems like Chainlink, Near, Oasis, Filecoin, LivePeer, and other well-known projects are all competing in this space, working on storage, oracles, decentralized AI tools, and compute frameworks. These are not small or experimental projects. They are some of the most serious infrastructure efforts in the industry. But when you look at where real building is happening, one network clearly stands at the top. Internet Computer Protocol now accounts for roughly a third of all development activity in the AI and large-scale compute sector across the top blockchain ecosystems. That means nearly 1 out of every 3 serious development efforts in this category is happening on ICP. Close behind is Chainlink, followed by Near, Oasis, Filecoin, and others. When a single chain commands that level of developer attention, it's not an accident. It's an early signal that something structurally different is taking place. The reason behind this momentum isn't marketing or price speculation, it's architecture. Most blockchains were never designed to run real software. They were designed to move tokens and handle relatively simple smart contracts. Internet Computer was designed with a completely different philosophy. From the beginning, its goal was to run full software systems directly on-chain at speeds comparable to Web 2, without relying on centralized servers like AWS or traditional cloud infrastructure. At the time, that vision sounded unrealistic. Today, the network processes hundreds of millions of queries every single day. What makes this even more important is how stable and predictable the network is. Unlike typical EVM-based chains where gas fees can spike unpredictably, ICP operates with deterministic costs. That means developers can predict how much it will cost to run their systems without fearing sudden fee explosions. This predictability matters more than people realize, especially for artificial intelligence workloads. AI systems demand consistent compute, continuous storage access, and stable execution. When fees fluctuate wildly, AI simply breaks. This is where ICP's technical model becomes unique. On most blockchains, smart contracts are limited in what they can store and how they operate. They rely heavily on external databases, indexing services, and cloud-based middleware. ICP introduced the concept of canisters, which function more like self-contained software units than traditional smart contracts. These canisters store their own data, run their own logic, serve content directly, and do not require external services to function. Everything the application needs lives inside the blockchain itself, which dramatically reduces complexity, failure points, and hidden dependencies. For artificial intelligence, this design is extremely powerful. When an AI agent needs to train, adapt, respond to user input, or perform inference, it doesn't have to move between multiple systems. It doesn't depend on fragile bridges or centralized endpoints. It simply runs. That's one of the key reasons developers working on AI-heavy tools are moving toward this environment. It gives them stability, control, and true decentralization rather than a patched-together hybrid. Another critical difference is how ICP scales. Most traditional blockchains scale vertically by trying to cram more activity into a single chain, which leads to congestion, higher fees, and slower execution as usage grows. Internet Computer scales horizontally by adding new subnets. Each subnet increases total network capacity. Instead of the chain slowing down as it becomes more popular, it expands its computational surface area. With more than 50 active subnets and more being added over time, the network is built to grow alongside demand rather than collapse under it. This architectural advantage is already starting to attract larger players. Quietly, without much marketing or noise, enterprise-level organizations and institutions are beginning to experiment with ICP for back-end infrastructure, storage systems, and compute-heavy applications. These aren't flashy announcements, they're early-stage infrastructure tests. At the same time, governments and policymakers in technologically advanced countries have started to raise concerns about the dangers of centralized cloud dependence. As centralized platforms accumulate more power than entire nations, the demand for sovereign and decentralized infrastructure naturally increases. The surge in ICP development aligns perfectly with the real requirements of modern AI. Real artificial intelligence systems don't run on hype. They require massive compute, large data storage, predictable execution environments, and fast response times. Most blockchains try to bolt AI onto systems that were never designed for such workloads. They rely on off-chain compute, cloud bridges, and centralized dependencies. ICP does not. Its base layer was designed around computation itself, not speculation, which is why this rise in development activity is a logical outcome rather than a trend. The biggest challenge for this ecosystem isn't technical, it's perception. Most people still view blockchains purely through price charts and token movements. They assume a project is strong or weak based on how a token performs over a short window of time. But infrastructure doesn't behave that way. Infrastructure grows quietly. It's like laying fiber optic cables underground. Nobody notices the work until the entire world suddenly becomes faster. The same dynamic is playing out in decentralized AI and compute. We are now entering the AI productivity era, and most people still only see the surface. They see chat interfaces, apps, and polished front ends. They don't see the enormous infrastructure required to keep these systems running. They don't see the storage costs, the compute cycles, or the architectural decisions behind the scenes. But those layers are exactly where the real battle is happening today. And ICP is positioning itself directly in that foundation layer. This leads to the turning point of the story. Artificial intelligence is moving into a phase where centralized foundations are no longer sustainable. Systems patched together from private cloud services, centralized compute providers, and fragile APIs will not scale to meet future demand. AI needs decentralized, permissionless, and robust infrastructure to survive in the long run. It needs environments where no single company can shut it down, censor it, or control its evolution. Chains that can provide compute, storage, and deterministic execution will be the ones that matter. Right now, Internet Computer Protocol is proving that it belongs in that small group, not through marketing, not through hype, and not through empty promises, but through real data, real development activity, and real architectural capability. This isn't a theory anymore. It's happening in real time. Developers are choosing to build there because their systems simply work better. Things become even more interesting when we look forward. What happens when the first wave of fully on-chain AI agents goes mainstream? What happens when decentralized applications built on ICP start serving hundreds of thousands of users? What happens when platforms like Caffeine AI onboard hundreds of thousands or even millions of people into a world where they can build, deploy, and own their software directly on-chain? These shifts won't just change applications. They will change ownership, control, and the structure of the internet itself. When users own their data through orthogonal persistence and applications live fully on-chain, the power dynamics shift completely. Platforms no longer own the users. Corporations no longer control the infrastructure. The builders and the users become part of the same system. And when infrastructure changes, everything built on top of it changes too. That's why these quiet architectural shifts matter more than price charts. So here's the real message to take away from all of this. The latest data shows that developers are moving toward environments that match the real needs of artificial intelligence. They are choosing platforms where compute, storage, and execution are native, not bolted on. ICP is becoming one of the strongest examples of this shift. This isn't about hype cycles, token pumps, or market noise. It's about structure. As decentralized AI moves from theory into global infrastructure, the networks that can truly handle real compute and real data at scale will matter most. Internet Computer Protocol isn't moving fast because people are excited. It's moving fast because its architecture matches the reality of modern computing. And once you see that, it completely changes how you view the future of Web3, blockchain, and decentralized artificial intelligence. So, what do you think about ICP's current position? Are you bullish on its growth in AI and DeFi? Drop your thoughts in the comments below. If you found value in this deep dive, don't forget to hit that like button and subscribe for more breakdowns like this. Thanks for watching. Stay curious, stay cautious, and I'll catch you in the next one.